Hello everyone, happy to see you again. This is your host Saurav from TechGeeks10. First of all, welcome to my YouTube channel. The channel is for them who would like to learn about Microsoft SQL Server, cloud, and other technologies related to the databases. I love to explore emerging technologies, fresh ideas, and continue to read, understand, and share with you all. If you like my videos, please go ahead, like, subscribe to my channel, and hit the bell icon for all future notifications. With this, let's start with today's topic about are you following SQL Server development best practices? Um, Before we approach, just wanted to bring your attention then that it was presented in SQL Saturday in Cleveland 2019. My name is Saurav, and I'm a certified trainer since 2017. I have more than 12 years of experience in SQL Server and AWS Cloud Platform. I'm certified, so you can see the list is followed here: MCDB, MCTS, PMP, ITL, AWS Solution Architect, and also I'm pursuing my PhD. Focus is more on the database side. Now, I just omitted the slide. I'll come back, but before that, I wanted to say what are the topics which are covered in this session. Those are the SQL Server Edition, the DB design, the DB configuration settings, the DB database modeling, performance tests, purging, database objects, index, Transact-SQL, version control, queries and store procedure, process improvement, and consultation, and the last one, which is not having space here, that is the security. So in this part 1 section, we would cover until indexes, and the second part basically will contain the remaining section. Now I'll go back to the previous slide, which says about structured query language. I kept it separate. So before I start, I thought we'll touch base about why SQL Server is a structured query language when we all talk about structured query language. So the standard query language for it is actually a standard query language which requests the information from database using the insert, update, delete, or using the select command. It also follows ANSI standard. It is a set-based approach. Remember, it's not a procedural approach, right? So typically, if this followed the three steps or the 3 points, basically we call it as a structured query language. It might follow other, but these are the main points, the major points, major areas why we call SQL Server a structured query language, because SQL Server follows all these steps basically. Now, what is a set-based approach and what is a procedural approach? So it's also very important to understand. When it comes to set-based approach, the the optimizer, whichever optimizer, so every database package has their own optimizer design, right? So the optimizer generates an execution plan first. So that actually creates an execution plan for SQL Server. Here we're talking about SQL, so focus is more towards SQL Server, and then the execution engine executes the plan to retrieve the data from this physical storage. So it's a straightforward, right? So the execution engine will run the plan which is generated, and then it will retrieve the data from the physical storage, and then processes the output in an efficient manner. So it displays the output in an efficient manner to the users basically. So this all 3 points comprising the set-based approach. Now, what is the procedural approach? So on the other hand, this approach says we query the database to obtain the query set. So it actually generates the query set. The previous one was something like it first generates the execution plan, but here it generates the result set first. And then we write the data operational and manipulative languages using either the loop or maybe conditions or any processing statements to produce the final result. So similarly, as you see for the cursors, right? So it uses the loop, condition, and other processing statements. So now it's clear what is structured query language, and what is the set-based approach and what is the procedural approach. But remember, SQL uses the set-based approach. So when you write any query or your thoughts and everything should be that you want to write the set-based approach and try to avoid the procedural, because that's where you are helping the engine to get the best results out of, for you basically. So moving on, this we already covered. The first point here is the SQL Server Edition, which is very important. Now, as you see, the it is always recommended for the developers to use the developer edition, but many a times you might have seen that they are using the SQL Express edition because that's readily available. Even developer is also readily available, but they start their work with the Express editions, which is okay for any very limited query. But again, if you're writing your production code and definitely want to test that in a lower environment, always it's better to use the developer edition, because developer edition is just like a enterprise edition. The only difference being that you cannot deploy that in production environment, I mean the developer edition, because Microsoft will not give any support. Obviously for production you need a production license, but developer editions are freely available. Same features whatever you see in the production enterprise, you can see in the developer edition basically. However, why we say avoid the SQL Express? What is the problem? So it has got many limitations, but out of that, the top five which I feel we need to understand is, when you use the Express edition, the maximum SQL Server memory which is used is 1 GB. So you are actually using 1 GB maximum SQL Server memory used by SQL engine. So now in your environment, if you have, let's say, 100 GB or any more, 64 GB or any other size of the memory, it cannot actually use that, because that's a restriction. So if you're writing a query which is bigger, which is complex, which is to have a join or other complex steps, it cannot actually performs, even it might break, right, because of the low resource availability. The next point is the 10 GB maximum size of each relational database. Now, if you need to design a database of 100 GB or maybe 50 GB in the lower environment, you actually cannot do, because the maximum size which is allowed is the 10 GB. So you have to be within this limit. The next point is no SQL agent. So in developer edition, you do not see any SQL agent. So if you are planning to do any tests using the SQL agent job, you cannot actually do, because the agent is not there, right? So you cannot actually do. The fourth point is the buffer cache limit for each instance is 1 MB of RAM, so which is very tiny, right? So you need a bigger buffer cache limit for your queries to run, obviously better, because 1 MB is very small in the buffer cache, right? And the last point is the relational DB engine is restricted to lesser of one socket by 4 cores. So that means in your server, if you have, let's say, 16 cores, 64 cores, or even beyond, you actually cannot use. You're only restricted up to 4 cores, because that's the limitation in SQL Express edition. So um, before using, be very careful that you should not actually use the Express. Even if you have it, try to onboard an enterprise developer edition, and then migrate your database into developer edition and continue to use your code basically. Now so this topic is I just finished up to here. There may be other considerations, but I think it's good for us to know why SQL Server Edition is very important, right? Now the next topic is the database design. Okay, so all the points which we have discussed here, the topics are very important. Obviously it doesn't make sense that one topic is important and we don't follow the other process. Definitely it will not be helpful. So we have to be careful enough while we design, because that's where we can get optimum performance. Now, when we talk about the database design, why it is important. So in the database, we have the database tables, obviously. So that's a major object which resides in the databases. Now, in real life tables, a standalone table is very rare, right? All tables definitely will have a primary table, and then we have a child table, a base table, child table, and that is supposed to be connected with the referential integrity like a foreign key and primary key, obviously. So always ensure that the relationship exists. Otherwise, in future, let's say if you miss to create a referential integrity, and then you are trying to delete or insert any record, it might only get inserted into the primary table or base table. It doesn't have any relation at all with foreign key, right? So while the developers, or you being a developer writing a code, and you need to delete or insert some record or want to fetch some record from child table, you might see that there's no relationship exist, and that might be too late when you're recovering these issues, right? So always ensure that the proper referential integrity exists. You are checking that point basically. And the third point is the choose the narrowest size of the column you can. So why it is important? Yes, it's important because let's say you want to create a integer column, right? It's a you know the size like a integer column size. Now suddenly you decide, no, I want to go with the begin, which actually is not needed because the begin size is double, like 4 bytes. So in that case, think like you need a narrowest size, because in your application you may not really need to create a double size column length, right? So always have that due consideration before you create any columns with a specific size. Next point is the choose the smallest and required data type, now which I said. So quick example is, let's say you want to create a column with a varchar column, right? And then you are suddenly decide to create an n varchar, which actually is not needed because n varchar uses 2 bytes or character per characters, but varchar actually uses 1 byte. So that means you can save your space in the memory, right? It doesn't occupy more there, obviously. And varchar stores ASCII code, and n varchar actually stores the Unicode data. So now Unicode is important. Let's say uh, in your application you're using a different coding, different characters, different wider characters, different other languages, and then you definitely need to use the Unicode, then you use the in-varchar. Otherwise you don't use it because that's waste of your space basically in the memory you are when you're going to reserve it. Now the next point is database configuration settings. So create appropriate database file sizes, my bad. And the next point is maintain the same configuration across different environment. So what is the create appropriate database file sizes? So let's say any application, you know that your database can grow, let's say up to 100 GB in a year, suppose. But you created an initial database size of 1 GB, and you have created a different database file growth, assuming you are saving the space. Instead of giving 100 GB, you are actually saving the space because it's only 1 GB and you have a plenty of space left. This is actually not a great practice, because instead of that, if you can create the complete 100 GB, you allocate that, then SQL Server will not be busy allocating space using the growth parameters, right? It already has that. It can only use when it has to actually create next to 100 GB. For example, you have a 200 GB of drive space, and then after 100 GB it has to allocate new space, then only it will grow. Otherwise it's already grown. It will just continue to insert the data, or maybe doing all the file operations. Now the next point is very important in the second bullet points, which you see, like equal data file sizes under the databases. Now for a database, let's say you plan to create 8 database files, maybe considering your the CPU size, or maybe you feel 8 might be a good number based on your tests. Then try to create all the database files with the same size, because file groups use a proportional fill strategy. Okay, so all 8 files, if it is part of a single file group that use a proportional file strategy, the concept is not like TempDB. So in TempDB, what happens? It works like a round robin fashion. So You essentially do not really need to create multiple files for TempDB. As I said, it's a round robin because let's say you have a 100 GB of or any other size of the TempDB, it will first consume the entire from start to end all the files, and then it will again start to insert all the data from the beginning. So it's like a round robin, right? But for the data files, it doesn't follow that. Okay, it uses a proportional fill strategy. So what it says is part of the proportional fill strategy. Um, let's say you have created, as I said, 8 files or even more files, let's say, or lesser number of files. It will first try to use all the files like equal basis. So it doesn't work like that it will first complete inserting or filling up the first file and then it moves to the next file. Not like that. It will try to use all the files and try to make a proportionate use basically, right? So that all files are being used properly, and that way the performance really improves. The third point is appropriate database DB file growth value, right? So it's always recommended that you use the MB, that is megabytes, instead of creating any percentages basically. uh, Start with the 64 MB megabytes and its multiple. That is very good results which has been noticed, which are noticed basically. And as I said, why we need the different database file, because it increases the DB file appropriately, so the DB engine will not be busy, right? So set up whatever the size you actually need it, and based on that, the SQL Server will not have to busy allocating the space or increase the block size at all the time. It can focus on some other critical activities. Mm, and then, as I already said, maintain the same configuration across different environment. So what does it mean? For example, you have a non-prod environment, right? Which probably a developer or maybe a stage environment. Try to maintain the same configuration as you are going to set for the production, because if you create a dissimilar environment, the problem is that um, let's say you do all your test with a lower configuration into the dev, right? And now you're taking that into a higher configuration. Then the performance, whatever you have tested in the lower environment, that will be widely different in the production, which definitely you don't want, right? So try to create an infrastructure with the same configuration. Try to match the configuration so that whatever test or result you're seeing in the non-prod, it actually matches with the actual production. Now, the next topic, which is also very important, is the performance and the load test, right? So why it is important? Because before you start the performance load test, adjust the DB file sizes, which we discussed earlier in the previous slide. And the next point is suspend the maintenance job during the period, such as the rebuild index. So why so? Why we need to adjust the DB file sizes basically before the activity starts? There's a definitive reason, because let's say you are going to do the performance test in the lower, obviously. So the the traditional file size which you aim to create in the production, it will not be the same while you do the performance test, because in that case you are trying to see how much load your environment actually can take. So based on that, if you know your database file can grow faster, and then create even a bigger file size. So initial file size will change basically in that point, right? So create a bigger file size there, and also increase the block size. So instead of creating 64 MB, let's say, you increase that based on your understanding about how much it can grow. That way SQL Server will not be busy allocating every time. So if you have any third-party software applications, maybe like Foglight, Redgate, Sentry, or any other SolarWinds, you can always see that it's busy allocating the space there every time. This many times the file has been grown, which is actually definitely not a good sign, right? The more you SQL is busy, it actually reduces the performance. And the other point which we say is, let's say you have set up the maintenance job, maybe rebuild index or backup or your statistics update job in the midnight. Now let's say you have the stress tests are running into the midnight of US, say timing, right? Maybe CST, EST timing, but the team is out in some other country, and they are running the test, right? So that might be a, afternoon or morning or different time, right? So they are good with that. So they are running all the test. So it's always better that we suspend or stop the jobs during the maintenance period, because this is not ideal to run all the jobs at the same time. Why? Because stress test is to mostly check the load in the environment, right? When you take that into production, definitely you are not going to test that in production like a stress test, right? So it doesn't hamper in that way. It will be steady use. So it's always better that you, before you hand over the environment to the team, you actually do all your maths and calculation and adjust the environment accordingly, and then only you hand it over. Okay. Now, the next topic is index. Yes, index. So I actually have here 4 point and here 3 points. So it's actually 7 points. Ideally, you can think about many other points as possible for indexes, but I feel the 7 points are very, very crucial. So what it says is use appropriate naming convention to avoid creating duplicate indexes, which is very important. Why? You might have noticed different projects, different people, different DBA, everybody have their own understanding of creating the index names differently. And that causes a confusion. Why? Because I know to create index with a certain naming convention. Other people, they just like that create a name, let's say. Um, so if we can create, instead of that, create a process or policy where we would dim to give all the index columns names, especially let's say you have 4 index columns, right? And then you include another 5 included column, or like that. Then try to mention such a way that you can easily identify from the name like how many index columns are there. So that way you can avoid the duplicate indexes up to a great extent, which really improves the performance. Next point is use appropriate column sequence when you create indexes, which is very important. So now let's say you are creating index with 4 columns, right? And then out of four, one column is something which is being used very much, then use that column as the first column, because SQL Server will see that column and then use the index accordingly, right? So if you jumbled up and then you thought, okay, it doesn't matter, I'm anyway out of 4 columns, even though I'm using first column, which is very important, but I put that into second sequence, it doesn't help basically. So put that into the first, because that's how the SQL engine will will produce you the best performance. The next point is do not create duplicate index, which we already discussed, because that greatly reduces the performance. It hurts the performance. Now, question is why? Because SQL Server engine is designed in such a way, right? So if you create duplicate, it doesn't mean that it will. Instead, it's more like a burden, because it's an additional constant check for you. So if you are doing an insert statement, or definitely it incurs or runs through 2 condition check, right? Which is not good anyway. It will be busy in doing all the conditional checks. And also identify missing indexes, unused indexes, which is something which we have to do in a continuous basis. It's not a one-time job, because over a period when the application usage is more, definitely you might see some of the new indexes which might have to create, or maybe you can see that you have explored some of the unused indexes which never been used, basically those indexes. So either create or discard as needed. But again, before you create or discard, test them thoroughly to any of the non-prod environment before taking that into production, because otherwise, if you take directly into production, that might hamper the performance. Maybe some application might stop to run. Maybe you might see that their application might be hung, or maybe running for aware, and it's not giving you any results back, right? So we have to be very careful before implementing anything directly into production. The next point is put heavily accessed tables and the non-cluster indexes that belong to those tables on different file groups, because it can improve performance. Yes, that's important. So for example, you have 10 tables in your database, right? Each table, let's say, have 10 indexes. So now how many indexes you have? We have 100 indexes. So instead of creating all the indexes into the same database file, better separate out and create everything into a different file group. So that way, what happened when you create the file group, try to see if you can even deploy them into a different drive. That way the performance is obviously better because all indexes are using or maybe even you create multiple files for the indexes, maybe based on the table usage, right? Whichever is been highly used, you separate out. Medium ranges, you separate out, and then whichever indexes are low, not used that much, then you create a separate file group for actually files for that. Okay, so test thoroughly before you take any such decision. Don't just like that create it in production. Always use your lower test environment before taking any decision. Now, the fifth point is keep the width of the indexes as narrow as possible. Why so? So for example, let's say now width of the indexes is actually related to the column length, right? So for example, you want to create an index, right, on some of the columns where you know it's which is very high, right? So instead of creating multiple columns, choose wisely which columns are actually you need it, right? Otherwise the overall size of the index will be huge because you have four columns. All four columns, individual four column size will be the total index size, right? And if you have if it is a bigger table, then definitely the performance also hurts because the maintenance time will be increased, right? So if you can choose a narrow index size, then definitely that you reduces the size of the index, reduces the IO read, and also the index maintenance, which is very, very important. Now the next point is avoid adding clustered index on a GUID column, which is also important. So for example, you created any of the columns, let's say order ID, or any of the like purchase ID, like those kind of columns, and you decide to go with the GUID column because you want to create that random function or whatever. But you have set up the GUID column, okay? But remember, GUID actually takes 16 bytes of storage, which is huge. Now, if you have a million record, you can understand each record is combining 16 bytes. So that means the size is huge of the index, right? Of the clustered index, which is dangerous. So always try to avoid creating, instead leave that like a heap. Probably that's should be even better instead of create a clustered index with a GUID column. Now, why so? Even we have to understand there's another column called as column type called as identity. So GUID is even the size is more than an identity column, right? So makes it even making the GUID is even larger, increases the IO read, and also it hurts the performance, which we discussed. And the last point, even not an exhaustive one, right? You can even explore more features for index, but I think I found 7 points, as I said, are very important. So the last point out of the index are prefer creating unique index over the non-unique indexes. Why? Because SQL Server engine, which is actually designed in such a way that it can search through unique indexes faster than the other, right? So when you create the indexes, always try to create them using a unique index rather the non-unique indexes because of the reason that the SQL engine is designed in such a way, such a fashion. So with this, we are closing the part one of the session. Please join me in the part two of the same discussion where we will discuss about the remaining topics as I promised. Before you leave, if you like the video and the presentation, please go ahead, like, subscribe, and share with your friends. Thank you so much for joining with me. I I would like to see you all in the next session. Thank you. Bye.